Hi, today we're learning about CCM6, ordering positive rational numbers. A rational number is any number that can be written as a fraction. For example, 4/5, written as a fraction. The number 10, because it can be written as 10 over 1. The square root of 25 is 5, and that can also be written as a fraction. And the number 0.7 or 7/10, because that's a fraction, 7/10. Some very important concepts. When comparing rational numbers, you can use a number line. When dealing with only fractions, use common denominators so you can compare. And when dealing with fractions and decimals, convert everything to a decimal. To convert everything to a decimal, you'll have to use long division. So let's do some examples together. It says compare, use greater than, less than, or equal to. So I've got 7/8 and 5/6. My very important concept tells me that I need to have common denominators. So between 8 and 6, my common denominator is going to be 24. Most people would think it'd be 48 because 8 times 6 is 48, but there's a smaller common denominator. That's why we call it the least common denominator. So like I said, 24. So 8 goes into 24 3 times. 3 times 7 is 21. 6 goes into 24 4 times. 4 times 5 is 20. And all in all, 21 is 24ths is bigger than 20 24ths. So I'm going to put a greater than sign in my little space there. Number 2, why don't you try this one, make common denominators and see what you get. Pause the video and then when you're ready, push play and I'll do it with you. So I've got 3/5 and 18/30. My common denominator is going to be 30. This one's already done for me. So now I just have to change 3/5 to an equivalent fraction with a denominator of 30. 5 goes into 30 6 times. 6 times 3 is 18. Well, looky there. I've got the same number, so I'm going to put an equal sign between them. Another way I could have done this is reduce 18/30 to see what I would have gotten. Okay, in number 3, I've got a decimal and a fraction. So in my very important concepts section, I noted that we need to change all fractions to decimals to be able to compare. And 3/4 is a very common fraction conversion, but if you're not sure what it is, we're going to do long division to figure it out. So to do long division, I would write 3 divided by 4. 4 cannot go into 3, so I need to add a decimal, bring it up, and add a 0. 4 goes into 30, 7 times. 7 times 4 is 28. And I have a difference of 2. Add a 0, bring it down. 4 goes into 20 exactly 5 times. So 3/4 is equivalent to 0.75. So you have to ask yourself, what is bigger? 75 cents or 65 cents? And the answer to that is 75 cents is greater. You can also call this 65 hundredths or 75 hundredths, but all in all, the 3/4 is greater than the 65 hundredths. Now that you've seen me do one with the fractions and decimals, why don't you go ahead and try these two on your paper, pause the video, and then when you're ready, push play and I'll go through it. Okay, so we've got 1/5, I need to change that into a decimal. 1 divided by 5, I've got to add a decimal, bring it up, add a 0. 5 goes into 10 exactly 2 times. So I've got 2/10 or 18/100. I can also put a 0 after this 2 to put it in perspective. You can also stack your decimals to see which one looking at the place values, is going to be greater or smaller. And when we do that, we notice the 2 is in the tens place is larger than the 1 in the 1/10 place over here. So my 1/5 is going to be larger than my 1800ths. And number 5, 1/9, also known as 1 divided by 9. Set up my long division here, and I've got to see how many times 9 will go into 10. 9 will go into 10 one time. 1 times 9 is 9. Take away, I'm left with 1. Add a 0, bring it down. I've got 10 again. So I would continue to put a 1 up and subtract 9 every time, leaving me with the same remainder. This is known as a repeating decimal. It's a repetitive process. So this 1 will go on and on and on and on and on and on forever and ever and ever. When I'm comparing this number, 0.1 repeating, to this number, 0.1, I've got to decide which number is larger. So just like I did over here, I can stack the numbers, dot, 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 and kind of see, lining up in my ones place, or excuse me, my tenths place, I've got the same digit, a 1. But if I line up the next place value is the hundredths place, I would actually have zeros here as placeholders. Well, in my hundredths place, a 1 is greater than 0. So this repeating decimal, 0.1 repeating, as a fraction is 1/9. That's actually worth more than my 1/10. If you wanted to convert this decimal to a fraction, it would be 1/10. And actually 1/9 is larger than 1/10. So some people would like to see the fractions and like to compare fraction to fraction. I prefer to change everything to a decimal and compare their place values. I think that's the easiest way to do it. So hopefully you got these right. Now we're moving on to putting numbers in order. So I've got a series of numbers here, and it just says order from least to greatest. So in question 1, I've got 7/9, 1/9, and 2/9. Well, luckily, they all have the same denominator. So I just need to compare their numerators. We're starting with the least, the smallest number. So in this case, 1/9 is the smallest, going then to 2/9 and to 7/9. These are my numbers written in order from least to greatest. In question number 2, I've got 1/3, 1/4, and 2/3. So out of my 3 fractions, only 2 of them have a common denominator. What I need to do is I need to make sure they all have the same denominator. So I'm going to do that now. The least common denominator between 3 and 4 is 12. That's the first that's the first number they have in common. So I've got to change all of these numbers so they have a denominator of 12. 3 goes into 12 4 times. 4 times 1 is 4. So I just made an equivalent fraction. Why don't you try these 2 out and see if you get the same answer I do. Once you've written equivalent fractions, then put your fractions in order from least to greatest. Pause the video now, and then when you're ready to see the answer, just push play and I'll walk you through it. So 4 goes into 12 3 times. 3 times 1 is 3. 3 goes into 12 4 times. 4 times 2 is 8. So out of these numbers, the smallest is this one right here, 3/12. But when I write my answer, I need to write the original number, 1/4. Then the next smallest was 1/3, and the last, or the biggest in this case, is 2/3. So again, let me just reiterate that when you write your answer, make sure your answer is using the same numbers in the same form as the problem first stated. Last but not least, I've got a couple problems I know you can do this one by yourself, but the next two look a little challenging. So why don't you pause the video, try this one independently all by yourself. When you're ready, push play, and I'll walk you through the remaining problems. So this is going to be, I'm going to make all of my fractions have a denominator of 10. I know that that's 1/2 is equivalent to 5/10. And then this is going to be equivalent to 4/10. So this is going to be my smallest. Then my next smallest and my largest. So did you get this? Hope so. All right. This next problem, we've got some decimals mixed in with some fractions, or one fraction. Let's take a look at what we see. First of all, I notice I have 4.6, 4.08, 4 1/8, and then 0.4. Well, looky there. All of these numbers started with a 4 as a whole number. This has 0. So I know this is going to be my smallest for sure. So I'm going to go ahead and put that one down, 0.4. That's my first value. That's my smallest. So that one's out of the way. 4 1/8. I'm going to have to convert the 1/8 part to a decimal. I know that when I rewrite this, it's going to be 4 point something. I need to figure out what that something is. So I'm going to do long division. Okay? So I've got 1 divided by 8. That's 1 divided by 8. That's what that means. So I need to add a decimal, bring it up, add a 0. 8 goes into 10 once. 1 times 8 is 8. Subtract, I'm left with 2. Add a 0 and bring it down. 8 goes into 20 twice. 2 times 8 is 16. Subtract, and I'm left with 4. This is the point where I see a lot of students stop and quit. Don't quit. You're almost there. Add another 0 and bring it down, and you get 40. 8 goes evenly into 40 5 times. So 1/5 is equivalent to 0.125. So if I have 4 1/8, I've got 4.125. Now when we compare our decimals, we need to look at the tenths place to start off, because our ones place all have the same digit, a 4. If we look at the tenths place, they all have different values in the tenths place. So this one has a 6, this one has a 0, this one has a 1. So I'm going to go ahead and put my numbers in order based off of their tenths place. So the next value after 4/10 is 4.08, then I was going to put 4.125, but like I said in the previous slide, you need to write the original number that was in your problem. So that's going to be 4 1/8, and my greatest number is that 4.6. So here is my final answer of these numbers written least to greatest. All right, we've got one more to go. Why don't you use the strategy we used up here by looking at the ones place first, picking out the smallest or the largest, and setting those aside. Convert your fractions to decimal, and then put these numbers in order. Pause the video and finish this problem, and then when you're ready, just push play and I'll walk you through it. Okay, so I know this is going to be my largest. I'm going to put an G next to it for greatest. This one's going to be, these two are going to be my smallest numbers because they both have a 0 just in the ones place. And then these last two are going to be kind of like my next ones. This is going to be my greatest because it's got a 3. Let me compare these two by looking at the tens place. This has a 0 in the tens place, so this is going to be the smallest number out of all 5 numbers. So 0.021. Then this one, 0.283. Now I need to compare 2.01 and 2 3/4. Let me go ahead and change 3/4 to a decimal. That's just 3 divided by 4. Long division. We did this one earlier in the slides. 4 goes into 30 7 times. 7 times 4 is 28. Subtract, you're left with 2. Add a 0, bring it down. 4 goes into 20 exactly 5 times. So 2 3/4 is just like having 2.75. So 2.75 is larger than 2.01 because if this were money, $2.75 is larger than $2.01. So I'm writing them in order from least to greatest. So here we go. My 2.01 goes next. 2 3/4 goes after that. And then lastly, 3 1/5. All right, I hope you caught on and learned something today.